Hey mechanics friends, in this lab we're going to take a look at creating the stress strain data for a tensile test specimen. So much like our friend Stelio that we saw in class and we put him in the machine and we broke him, we're going to do the same, except we're going to do it with a piece of rebar that has a reduced cross section that's been filed down so that we get kind of the same behavior as we would as a standard UTM specimen. This is the universal testing machine, or UTM as we call it. This is what's going to pull the steel apart in this case. One of the things in terms of safety for this lab, there's just two major things. Number one, this machine is capable of generating very, very high forces. So we want to make sure we keep our hands clear. As we operate during the test, only one person will be kind of in and around the machine, and they'll have full control of the machine. So only one person is making the motions, clamping and unclamping the specimen, and moving the crossheads as appropriate. So that way we don't ever want to put our hands in any situation that they could become smashed. So this machine will smash your hand with will not feel bad about it. And then you definitely want to keep your hands clear of the grips. We have some wedge type grips, which we'll be able to get these in here, and then we'll be clamping it in place and then breaking it. So that kind of gives you an overview of the lab. That's the biggest safety issue. The other safety issue is just that as we break the tension specimens, pieces could fly, so we will wear safety glasses during our lab, and then the general lab safety also you have to meet those requirements, so closed-toe shoes and pants. Alright, so we're going to go ahead and get started on this lab. So I'll grab my safety glasses and get them on. So to get started with the lab, like we did in class, we're going to need to mark out the initial diameter and the initial length of these specimens. So go ahead, you have your test data sheets here. We're asking for the initial geometry, the initial diameter, initial length, and then you can calculate the initial area. So you can grab a pair of calipers, take those calipers and measure. Go ahead and take a couple measurements. You want to find the smallest area, so the smallest diameter in this section, and you can feel free to do these measurements in millimeters, as our machine reads in newtons, I think is how we'll get it, but either way, just know what units you use as you do this test. I go ahead and take like three measurements on your specimen so that you get kind of an average reading for your diameter. Also, you want to have your initial length. So the initial length preferably is 25 millimeters. That's going to be the length of our extensometer. And so go ahead and you can take your calipers and move them to exactly 25 millimeters. And when you do that, almost there. When you do that, go ahead and just line it up with the specimen and create two little dots on there. And you want to go for the flattest part of the specimen that you can. Just go ahead and add two little dots. So that will be our initial markings. When we get it set up in the UTM, we'll have our extensometer set right on these marks so that we can get our measurements. Also, after the specimen breaks, kind of like Stelio, after Stelio breaks, he's somewhat stretched, you can then look at those two dots and measure the final length of your specimen, as we'll need that to figure out the percent elongation. So you would kind of just piece these two pieces back together, measure the distance between those dots, and you'll get your final length. So I think that's pretty straightforward. We're now going to shift over to getting our specimen into the UTM. So I'll walk you back over there. So before we go ahead and get it in there, go ahead and get these two rubber bands on there. And so we're just going to hook those on So that they're initially, these are what hold the extensometer to our specimen. And then we've got the extensometer. This is what the extensometer looks like. And so we're going to put these, there's two little knife edges or like razor edges that we'll put right on the markings that we made. And then we need to hook those rubber bands around the gauge. This will keep the extensometer from falling during the test. We have this little like crochet hook that they provided with the extensometer to go ahead and loop this around. Alright, so once we have this in place, and we got it all looped around, we'll be able to put this into the test machine. We'll get it into the V-grips, and then we'll tighten the grips accordingly. I'm going to actually, that will be the the basic prep. When we get into the actual lab, I'll show you how to do that. And